Welcome to grade 10 math. We're in unit 3 quadratic relations and starting a new chapter on binomials and factoring. So today is lesson 1 and we are going to multiply binomials. Just a quick recap of a skill we learned earlier in the course called Distributive Property. And so we learned that if there's a monomial, this is a monomial times a binomial. And we use distributive property. So hopefully you remember what we did in these cases. So what we did was often we just looked at one sometimes, and as we went through, we learned how to do more than one. So the first step is to expand the monomial into the binomial. So the first step is 6 times x, and then 6 times negative 3. So you're going to have, you could write it out like 6 times negative 3. And then moving on to the next one, you have a negative here. So you have negative 1. It's like saying negative 1 times 5 is negative 5. And negative times negative is going to be a positive and 1x. Okay, so we're just left to figure out this, work out these numbers. So 6 times negative 3 is negative 18 minus 5 plus 1x. And now we gather like terms, so 6x plus 1x minus 18 minus 5. Now we have the x terms together and the non-x terms. So 7x minus, what's that going to be, 23. Okay, that's as far as we can go. There's no further, these are two unlike terms, and this is where it ends. Okay. When we did that, we sometimes talked about doing this first step in your head. Some people just did that in their head and they went straight to here, which is fine. So again, this was a monomial times a binomial. Okay, on to the lesson now. By the end of today's lesson, you'll be able to expand and simplify expressions involving one variable using the process of FOIL. This is going to be a binomial times a binomial. Okay, so we just looked at an example where we have a monomial times a binomial. Okay, and we got another binomial. But notice the pattern here. So 6 times 2 is 12, and x times x is x squared. 6 times 4, so 6 times 2, 6 times 4 is 24, x times nothing there is still x. And we are going to find this is going to be common in all quadratics, which you kind of already know that you're going to see that squared number. Okay? Now, just before we go to what FOIL is, I just want to tell you what the purpose here is going to be. Okay? By knowing the binomial expressions, okay, so these things, by knowing the binomial expressions, we can determine the the x-intercepts. Remember what the x-intercepts were from last unit of a parabola, right? The zeros. And we knew how it was good to know the zeros because we would know how to graph it. We would know when the ball left the ground or when the ball hit the ground. So that's ultimately why we're getting to this point and why we work with binomials, because these actually, what's in the brackets actually help us find the x-intercepts. Okay, so now on to FOIL. So FOIL, all right. First, step 1, step 2, step 3, step 4. Okay, or FOIL. So what this means is the firsts, actually let's color code this somehow. First, outside, inside, last. Okay, so the firsts are these two. Let's get red. The first in both brackets. Okay, so the outsides are these two. All right, the insides are these two. And the lasts are the last ones in both brackets. Okay, so what we're going to do is our step number 1 is our, okay, first to first. All right, outside to outside. So that was step 1, right? That was step 1. Okay, outside to outside, outside to outside. That's step 2. All right, now inside to inside. Well, that's step 3. The marker's not very clear. Okay, and finally, last to last, and that's step 4. All right, so look, this is step 4. This is the result of step 4. This is the result of step 3. This is the result of step 2. I just realized I put an I there. Although we can write that. That actually might help. So this is step 3, and this is step 1. Okay? Or we have, F, O, I, and L. Okay, long story short, it's best to just practice these, okay? Basically what happens is the A has to be distributed, just like our distributive property up here. The A has to be distributed to both the C and the D. Okay, so once, twice. But we have this second thing, that's why it's a binomial. The B must be distributed to C and D also. So that's what's happening. A to C and D, B to C and D. So let's give a couple practice questions. All right, I'll stick with our colors here. Foil, F, O, I, L. So first, okay, x times x. So notice how I start an equal sign here. There's nothing on this. This is not an equation, so there's nothing over here. In the future, you'll have y equals, something, 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 because that will be a quadratic equation. But for now, it's just this. So x times x is, well, let's do an expanded version. So that x times x, okay. The next one is outside. So the x is an outside and the 2 is an outside. So plus, always do a plus sign in between every step. Even if it's a negative, I'll show you what happens on the next example when we see a negative. So x times 2 plus 4 times x, okay, plus 4 times 2, okay, in this last bracket. All right, so we have x times x is x squared, 2 times x is 2x, 4 times x is 4x, and 4 times 2 is 8. Now, we gather like terms at this point. Like terms. Okay, so here we only have 2 like terms. There's x squares, there's only one of them, there's non-x's, and then there's x terms. So finally, let's do our final answer here. So nothing to change. We have x squared. 2 plus 4 is 6x plus 8. All right, and that's our answer. So that's our final answer. Okay, let's do B over here. Again, color coding. X times x is x squared. Okay, green outside to outside is x times 6 is 6x. Notice I'm skipping this first step where I expanded. This is called expanded version. And so hopefully you're understanding that. You can skip right to doing it this way if you want. Now, negative, oh, I did say I would tell you, what if I had a negative? I'd still do plus negative 1 times x, okay? And plus negative 1 times 6. Now, when I work those out, the negatives will come out. Okay, x squared plus 6x. Now, here comes the minus. Plus a negative is a minus x. That's a 1x, of course. Negative and a positive minus 6. Okay, we have like terms again. And now we have, oh, come on. X squared, now 6 minus 1 is 5x, and minus 6. And that's it. That's your answer. So I want to show you one other way that this can work, and because I want you to have 2 tools to be able to do this. So some people like to make a grid out of this, and I actually encourage you, probably the first way to do this is to use a grid. I'll show you how to do this. So make a grid for almost like a tic-tac-toe grid. Actually, it is very much like a tic-tac-toe grid. So what you're going to do is on one side, you're going to put these. And on this side, you're going to put these ones. Okay. So the green will be the 2x and the 1 plus 1. Okay, on the blue side, you're going to have the x and the minus 10. So you're just taking the 2x and the 1 and splitting them up. You're taking the x minus 10 and splitting them up. Okay? So now what you do is you cross these. So what's happening is I could color code these two. Look how it's the first and the first, the first and the first. So what's the first and the first? So 2 times 1 is 2. X times x is x squared. All right. What is the outsides? Well, the outside is 2 and 10. So look at that. Here's the 2. Bring it over across times the 10. And what are you going to have? 2 times 10. So 2, a positive times a negative. 2 times 10 is 20x. Okay? And I'm color coding it so you sort of see these steps are still here. So now we have the inside and the inside. And that's right here. Okay? So 1 times x, where they meet, is 1 times x, 1x. Okay? And finally, the last and the last, the FOIL, 1 times negative 10. So a positive times a negative is a negative. 1 times 10 is 10. Now you might be going, well, how am I supposed to turn that into an equation? Well, we also have the like terms will always be in the middle. So if we do it this way, just like up here, the like terms always show up in the middle. The like terms are always diagonally from each other. So my final answer, I can go straight to it, equals, well, not my final answer. Let's see, 2x squared minus 20x plus 1x minus 10. And you can still gather your like terms. Or, you know what, just do it right here. You could figure it out right here, add these up, or subtract them in this case, but you get the answer. So 2x squared, negative 20 plus 1 is negative 19, x minus 10. Okay, let's go on to the next question, D. Now we see something a little bit peculiar here. There's only one monomial. However, it's got a squared. So what does that mean when we see that? So when we see this, we can actually expand it to look like this. X plus 5. This is exactly what I want you to do. X plus 5. Now, I like using the grid. Maybe you will like it too, but let's try this out. So again, do like a tic-tac-toe box. Maybe try and make it a bit bigger if you can. And so we're going to put one side of it, x plus 5, and the other side of it, x plus 5. And what happens when we combine all these? So what's x times x? Well, 1 times 1 is 1. X times x is x squared. What is x times 5? 5x. I'm trying to stay with the color coding there to help you guys out. What is 5 times x? So they meet in this box. It's like you multiply into this box. 5x. 5 times x is 5x. And finally, what's 5 when it meets with 5? 5 and 5 is 25. Okay, so let's try and combine these middle terms. You know that's going to be 10x. So we can go straight to the answer. X squared plus, remember this is 10, 10x, 5x plus 5x is 10x. You're not going to square that because look at all the other examples. They were single x's and they're like terms. Okay, and 25. So this is our trinomial. Now, this is we didn't say this yet. We have a trinomial. So very good. Okay. So in each case, most of the time we get a trinomial. And that's what we know what parabolas and quadratics look like. They look like trinomials when we get them all written out in standard form. So, very good. Let's move on to word problems. And we have one example to talk about. Donna wants to paint the walls of her bedroom. The dimensions of her wall are given as, let's say that's the base of the wall and that's the height of the wall. Write a quadratic expression that represents the wall. Write a quadratic expression that represents the area. Well, this is what we're going to see when we want to do this. So when we want to do, quadratic expression that represents one wall, then 4 walls. So here is where we're going to use area is, just say length times width. Okay, and this is going to be a binomial times a binomial. Okay, or FOIL. All right, so write an expression. They didn't give us much room here. So again, I would want to do, you can do FOIL. I'll do it both ways. So let's say I want to use a chart, or I want to use FOIL. So I might as well show you both ways, and you can start deciding which way you like the best. Okay, so our expression is x plus 1 times 4x plus 1. So if I was to do this as FOIL, we can try that. Okay, so x plus 1 times 4x plus 1. Okay, let's do the chart first. Okay, so one side of this binomial is going to go here, x and 1. All right, so we're doing this whole thing comes over here. This whole thing's coming to the top. Four x is the first one, and 1. Okay, so when we combine these, 1 times 4 is 4. X times x is x squared. Okay, and the next one was 1 times x is 1x. And in this box, 1 times 4 is 4, and x is still there. And then finally, meeting in this box is 1 times 1 is 1. So we have an expression of, now you can combine these, and we will have an expression of 4x squared. Well, what's 4 plus 1? 4 plus 1 is 5 x's, and finally plus 1. Okay, so that's using your chart method. You're welcome to do that if that makes sense to you. And we're going to use some space over here. I do want to keep both options open. So again, FOIL we said was the first and the first. First and the first. So ignore that this sentence is here. So what is x? 1 times 4 is 4. X times x is x squared. Okay, we said we do the first and then the outsides. So outside, and we have x times 1. Oh, yeah, x times 1 is 1x. Perfect. Then we have our inside, I for inside. What is 1 times 4 is 4, and 1 times x is just 1, is just the x. And finally, our last step, our last and our last for L. Last and last. So what is 1 times 1? That's simple enough. We have our combining like terms, just like the same ones we had over here in the yellow. So our final answer is 4x squared. Now 1 plus 4 is 5x and plus 1. Notice that 5, we got it in both spots. Very good. Okay, so now that we have the expression, Now we go to, that was for A, so step B says write the expression for the quadratic that represents the area of the entire room now. So notice that this is one side of one wall, see what we have. So now we're going to have to multiply that by 4, okay? So multiply by 4 walls. So we have to use our distributive property in a different way now. So if I have that, then we're going to have equals, we'll have the 4 walls times our expression. And we can call that the area. So let's say, I'll put that on up in a second. Okay. And we'll say that's the area of a room. The A of a room. Okay. All right, so how are we going to get that? We're running out of space here, but we're going to distribute that to each of those. And so if I do that, I will have the area of a room. So that's going to be 4 times 4 is 16x squared. Okay, so 4 times 4. And then 4 times 5 is 20x. And then 4 times 1 is 4. Sorry about this being so crowded. There's not a lot of space here. Okay, so then we can go to this next step. So now they're saying, well, what if we actually know one of the dimensions, that every x represents 2 meters. So if we know that, then we can say A of the room, the area of the room is 16x squared plus 20x plus 4. And then we're going to put the 2 in for that. 16, and then the 2 goes in, 2 squared, plus 20 times 2, plus 4. Okay, let's bring that up here. And so what do we have? We have 16, and then 2 times 2 is 4, plus 20 times 2, plus 4. And we continue. That's going to give us 64 with our calculator, I guess, plus 40, plus 40, okay, is 104. 104. So therefore, the area of the room is 100. Oh, I think I made a mistake here. 64 and 40 is 104, plus 4 is 108. 108 meters squared. I promise you I'm not this bad of a writer. For some reason the pen's not working great. Okay, so then we need a cost equation. So it's asking us what will be the cost if it's the area times the rate. So the cost equals, the area is 108 times 0.5. And so half of 108 is 54. Therefore, it will cost $54 to paint her room. There we go. All right, so that should do it. Well, we've shown how to do FOIL. There's two different ways. You can use a chart. You can use the distributive property of FOIL to get turn two binomials into a trinomial. Okay, we remember to look for these patterns where the middle, when we do FOIL, the middle two terms gather. If we do the chart, well, the two middle diagonal terms also collect like terms. So, and then finally we saw how this could be applied to, a dimensional question um, of a room and so on and so forth. Okay, so thanks for watching, and we'll see you next time.